On the LinkedIn.
So, yeah, on the LinkedIn.
Okay,
So, am I live?
it is showing pre-live at my end.
Okay. Yeah, it says live. So, okay, I will remove from the screen. Okay. Thank you. See you. Thank you. Thank you so much.
Okay, yes.
Hello, everyone. Can you hear me? Yeah, I think I'm live right now. Uh, so, some of you guys, please confirm if I'm live, right? Hello, everyone. This is Harsha. I have overall 18 years of experience in performance engineering, and today I'm going to go talk about hardware performance engineering, and so why you should think about it right now. And if you are a performance engineer in the software domain, so if you are a performance engineer like working on different software applications or portals which you want to like you would have worked with JMeter or load runner or any of these of the software tools, then you would be familiar with software performance engineering. So that is where I think the sorry, just a minute. Let me. Yeah, Lokesh, am I live right now? Right?
Not on LinkedIn, sir. You are live on this website.
Oh, okay. So just a minute. No, I did get that I'm online on LinkedIn. So you can just refresh and see.
Yeah, I refreshed, but again shows the event will start soon. Wait for the host to start.
Okay, but it is showing me live. So you can just check. I checked on the my profile and it shows I'm live. Because like you said, I just posted it on uh, my profile page actually.
Yeah, in my account it shows me.
So okay. hmm Okay, for now. Okay, cool. I got the confirmation. Sorry. So this is the first time I'm going live on LinkedIn. So that is where it is a little bit of technical glitches here. Okay. I hope I'm clear about what I wanted to present today. So let me start sharing my slides. So yeah, so this is about hardware performance engineering. So mainly, if you have worked in companies like Infosys, TCS, or HCL, so you would have worked in center of excellence or performance teams, which take care of working for some clients like Deutsche Bank or any of the telecommunication projects or any of the banking projects, BFSI projects. You would have worked on uh, how do you do performance testing on the software side using load runner, JMeter? You would have your own server setup and you would be doing performance testing and monitoring and analyzing why particular it's not able to scale. The scalability aspects or the performance issues may be related to transactions per second or response time, and also uh, what is you know uh, what is really causing the issues in respect to the software side. But you're not really very much available on the hardware side of things, right? So that is where this whole slide presentation is about. And so let me go to the next slide. So we have here, you know, just a minute. So I'm just keeping everything pretty much, so the agenda of this session is about understanding why, if somebody is in the software side of performance engineering, he's a performance tester, so he wants to move to the performance engineering and the hardware side. So what is the difference here? So software performance engineering is you would be more working on the application side of things. Hardware side is you would be you would have hosted your application, how the environment would be, the staging environment would be there on the your servers or data center or public cloud or private or hybrid cloud. So there is a lack of understanding of hardware systems among the junior or mid senior level performance engineers. So the idea here is what you have to do in order to get into this side of things. So I'll talk about more about why you should transition now, and how you can transition to this position, and what are the benefits, pros and cons of this move, right? uh, so mainly, and also I will be talking about more on the complexities of hardware performance metrics, what tools you can use, how do you monitor the utilization of servers in this case. It could be OLTP or OLAP workloads. Anything is like possible, right? So, and then we have the integration with software performance engineering. Of course, everything works on the server, but so usually when you work for a client, they would be trying to analyze the performance of the software applications. For example, if we take the example of banking services, then it could be a transaction where you have cash deposit, cash withdrawal, balance inquiry. So this could be the different types of uh, you know uh, performance engineering transactions that could be happening, and you want to check whether the particular transaction TPS or response time is affected. So you will be, and also you will be scaling the number of users, right? 10,000 to a lakh or something like that. So then, the limiting factors could be the operating system level or the application level, JVM level. So that is something you would be dealing with in the software side. But when you're going in the hardware side, it is more of trying to understand how you can improve the core computing capacity of the server. It a lot of depends on the number of configurations, the configurations of the server, number of cores, number of chips per socket, how much is the memory, kind of memory DIMMs that are used, or it could be SSDs or HDDs. So generally, when you are testing the some of the workloads, we call it not applications, we call it workloads. The You have spec CPU for measuring the CPU performance, and you have spec JBB for measuring Java performance on the servers, and you have MLPerf for measuring the AI workloads performance. You have various kinds of AI workloads. There is CERT tool for energy efficiency measurement, Java performance per watt, and so like this, there are various tools, OLTP and OLAP workloads. Primarily, they belong to the standard consortiums like SPEC and TPC, Standard Performance Evaluation Corporation, and Transaction Performance Council. So mainly SPEC deals with kind of virtualization or single system performance, right? could be vertical scaling, or it could be horizontal scaling when you scale out number of servers, and could be on the OLAP is analytical processing, more of big data, data warehouse, or cloud performance, right? So those things are taken care by the uh, the TPC council, right? So now there are a lot of things are changing, and you have the you know uh, the cloud performance, the data warehouse performance is measured by a completely different set of environment that you would have. You could have the user plane, control plane, and it could be a quite diverse kind of environment that you would have when you are measuring the performance on the hardware side. So how do you analyze on the software side and hardware side are very much relatable. Uh, Even on the software side, you do the operating system tuning, you do the JVM tuning, and you do kind of configuration, whether it is right or not. You check those things, and also on the uh, you would check how do you scale, and you could have different, for example, load runner scenarios, and you would have tools for measuring the resource utilization of your multi-tier architecture. Now the whole architecture of the software that is deployed is getting very complex, right? So those things are pretty much on the similar lines. The concepts are similar, but when you go on the hardware side, it is more of how do you measure the, suppose your single system of HP, or it is based on Intel processor as well, Broadwell, the latest is Sapphire Rapids, and then you have the whole configuration of the even the processor that you're using, the DIMMs, the memory that you're using, the storage type of storage that you're using matters a lot. So that's about understanding the complexity of hardware performance metrics, the tool selection, utilization, and the integration with the software performance engineering, and there are also resource allocation and budgeting that happens, right? And you have a similar way of DevOps, continuous integration challenges in hardware performance engineering, and how do you keep pace with the technology changes and transition to hardware performance engineering. So I will talk about that very quickly now. So let me move to the next slide. So what do you mean by lack of understanding the hardware systems, right? So it's about whenever you think from the software side of things, so it's more of you're dealing with the TPS response time, and many software performance engineers actually may not have a deep understanding of hardware architecture and its implications on performance. So this gap can lead to difficulties in optimizing hardware components and understanding how they interact with software applications, which is crucial for performance engineering. Okay. Uh, so so it's about so when I talk about this, the so you would be wondering what is the difference, right? So before the hardware systems are released to the market, and generally what happens is, suppose you have a hardware vendor like HP or Dell or uh, Super Microsystems. There are so many. So they sell the servers to a particular software vendor, say a client, maybe American Express. They are looking at scaling their number of users. So they approach HP or Dell. They come up with different configurations of servers, and then they package that and sell to them as a solution. So they pick up and they test on the client side. So that is when the software side of things comes, where performance engineering testing is going happening from the software side of things. But on the hardware side, even if it before goes on a sale, So how do you improve the performance of the particular server architecture? It could be Intel, AMD, or you know, uh, uh, sorry, it could be many chips that are coming up these days. Even Google has its own TPUs right, and also you have Apple, you have ARM. So everybody has their own chips today, and they are building up the server architecture to actually see how the performance of these matters. So how do you improve the performance at this site? So there is two things that comes up. So one is uh, you know micro benchmarking. So primarily we talk about benchmarking, okay, and it's about just a minute, yeah. So we talk about benchmarking, and you have micro and macro benchmarking, right? So micro benchmarking is, let us say I want to measure only the performance of CPU. So how do you do that? If you want to measure the performance of only memory, how do you do that? If you want to measure the performance of SSDs or HDDs, how do you do that? So I'm talking about only single cluster here, single system here. So we call it system under test. Also, you could be having, clusters of systems. You could be having data centers. You could be having a private cloud. So all these matter a lot when you are trying to either scale up or scale out. Scale up is you are having one big system. For example, HP has Apollo or Synergy systems, which are pretty huge. Apollo, especially, pretty huge. I don't know about the latest things for layered systems that we have, but on the side of we call it ODMs and OEMs. ODMs are original design manufacturers, right? Uh, so OEMs are equipment manufacturers. So as a solution, you sell the server. So the chip could be from different company. The memory module could be from some other company. The disk could be some Mellanox, or network NIC cards could be from different companies. So all this come together, and they sell as a solution. Those are called OEMs, right? So they build reference architectures depending on what kind of solution you want to sell for a particular uh, uh, customer or use case, right? So, so this kind of understanding of the hardware systems is very much crucial and important. Uh, so, yeah, so that is where this you need to understand on these aspects. The complexity of hardware performance metrics is pretty much high, like I talked about micro and macro benchmarks. And micro benchmarks, like I said, if you want to individually measure the performance of the CPU, memory, disk, storage, so that is where the micro benchmarks come in, like spec CPU, spec JBB, or you have uh, the some of the particular cases of in case of hardware we use Terasort, or we have something related to big data. You could have Spark, Apache Spark, or you could have Hive in combination, HDFS, right? So the Terasort is where you measure the kind of uh, the I/O that happens on the hardware side, SSDs that you might have in the cluster, and so the macro benchmarks are mainly kind of CERT, server efficiency rating tool, or it could be again the TPC DS, right? So this is decision support system. So this has about 30 queries, which tries to mimic uh, the OLAP workloads, mainly related to the big data side, right? So in TPC XBB, Big Bench is again big data related benchmark, where you have about sorry, the TPC DS has 99 queries, and TPC Big Bench has about 30 queries. So they kind of mimic the typical use case scenarios of testing your analytical applications workloads. So before the server goes to the market for applying these different kinds of workloads or applications on this, the stack could be very different. The hardware and software stack could be a lot different on the uh, you know when it goes live, right? So before the research department, the R&D teams, they work on. I'm trying to simplify more because I don't know the kind of audience that we might have. It could be junior engineers or senior or mid-level engineers. So that's the reason why I'm going in a little bit of depth on these things, right? So the complexity here is again understanding, like I said, what tools you can use, right? Different kinds of workloads. So now I'm on the tools and utilization section. So I think, sorry, there is a misalignment of the slides here. So the tool selection again is developed by, suppose you have, let us say, a customer and comes and he wants to compare HP, the hardware from HP or hardware from Dell or the hardware from, it could be small systems from AMD or the processor companies itself, ARM, right? It could be possible in future, near future, maybe it possible. Or a long time I worked on Azul systems. They had Vega processors. They had their own systems called Vega, right? So we have they had now they have the Java Zing product. So so these things matter a lot in terms of tool selection. It's about these are developed by the consortiums like Spec TPC and so all the hardware vendors, they come together and they developed a workload which is common across. So it's like, let us say uh, you're going to any uh, store, e-commerce store, or wherever you want to buy your utilities, right? So you have, say, the wheat from different companies. So how do you measure? How do you make a decision on which box of wheat or cover of wheat I should buy? So you will go for the specifications on where it is grown, the quality of that, and based on that you make a decision, right? So similarly, you make a decision even if more simpler ways. If you take butter, right? You go Amul is there, then you have uh, Nandini. I'm talking about the local things here in Bangalore, India. It could be quite different across the world, right? So you make a decision based on the ingredients, the quality, and way how it is manufactured and how it is catering to the needs, right? So these things come into picture in the hardware side also, depending on, for example, the most relevant one would be when you're going to buy your mobile, right? So you go and buy Apple or go and buy an Android phone. So you check the configuration of different mobile phones. It could be the RAM, CPU that you could use. It could be quad core, octa core, right? So and the memory could be different. The disk that is 128 GB or something, right? So similarly, a lot of performance matters in terms of the configurations that you might have in the server and the whole architecture of the data center that you could be using or the private cloud, a group of data centers in the private cloud, that also differs a lot. So these things quite matter a lot, and so it's a continuous process of tuning the using different tools like OProfile, Perf, and it depends a lot on how do you which part of the architecture you need to understand the CPU architecture, whether you're using Intel. The latest one could be Sapphire Rapids. Then we have Cascade Lake. You have Skylake before. A lot of other as well. You have Broadwell. So many over the years, right? So you have Intel itself has Xeon, Platinum, Bronze, kind of different variants of processors. Uh, so all these matter a lot on the performance. If you do deep dive on the CPU, you would look at L1, L2, L3 performance, or how the chip design itself it differs a lot. Whether it's a CISC or a RISC, and whether it is a lot of things matter. Even in case of AMD, AMD has its own processors called Genoa. You have Naples, Rome, and the architecture quite differs a lot in each case. So all this matter, the performance matters a lot. So the way to go about the tool selection is done by the industry consortiums, because one person cannot decide on performance, because if they start doing that, then there is no apples to apples comparison, and the customer cannot really decide on which to choose. So everybody has to go to a standard, and then the customer comes there and they make a decision based on that. So the lot of ecosystem is changing really with the Gen AI right now, and a lot of things matter in terms of performance. You need a lot of hardware for the training the data on Gen AI, right? So you have LLMs, small and big LLMs that have come up. Each company has its own LLM today. You have Meta, Llama, you have Google's Gemini, and you have each one of them come with their own LLMs, and training them and testing them is a big challenge right now, because you have huge amount of data, right? Uh, so yeah, I mean the utilization part again. I talked about perf and O profile, and there are many other tools depending on the architecture, the chip you are using. You have VTune of Intel, and you have Mu profile. Uh, if you consider about AMD, right? So the specific, even Qualcomm, all these guys have different ways of measuring these performances. So hardware side is you need to understand more on the CPU architecture, how the server composition is, and how it is deployed as a private cloud or public cloud or hybrid cloud. You have Google, GCP, AWS. Everybody is using on that. They're using their own kind of set of things on the cloud side. Cloud side it is much more easy. So what we are majorly talking about, how do you improve the single threaded performance on a particular processor if you have uh, you know on-prem kind of solutions, right? So on-prem is you have dedicated system or a group of data centers that is used in your uh, particular use case, right? So integration with software performance engineering. Again, I gave a picture about how everything integrates together, right? So the ODMs they come up with for example, IBM had its own power chips, right? P7, P8, P9, P10. I think now the latest. I'm not sure about that. So when I was there till a couple of years back, it was P10 that was there. So it has its own IBM power architecture, right? So you have single chip module, multi chip modules. It could be pretty much different right now. Uh, so when you optimize the performance on the hardware side, all these components, subcomponents in the system, other aspect would be on the energy side, energy efficiency side. Uh, so, for example, a minimum, like you have in at home, you have a bulb or can uh, it, the normal incandescent lights. So these differ a lot when you go and buy different variants of these, right? So similarly, the power consumption there could be very different. So in case of servers also, the minimum server that usage I've seen, like 80 watts or uh, 40 watts. That's like the idle situation, a very much idle situation. We call it idle power save. That is like when the just system is brought up and the power usage consumption there in that phase is idle power save. And you have also the server when it's at the max utilization, the DVFS comes into play, dynamic voltage frequency scaling, which measures the resource utilization of the system and then gives input to the processor subsystem to vary the frequency of the cores. So the P states and C states they matter a lot. It's pretty much processor dependent when you talk about those. That could be a much deep dive talk. For now, I will just talk about uh, you know the high level things about the resources and allocation and budgeting is basically about the kind of the licenses that you use on the server architecture, and usually the per core performance is what matters. The number of threads you can run. We have something called hardware threads, and you have software threads. Software threads are mainly the uh, you know application side. The hardware threads are nothing but the number of uh, we call it hyperthreading. In case of Intel, it is SMHT2, and in case of IBM, it was SMT 2, 4, and 8. And again, AMD as I think hyperthreading SMT 2 again, without enabled single threaded. So there you have the logical the CPU is divided into smaller CPUs, and I mean, this is on the logical side, not physically. So those, when available for processing, they are called the logical threads, right? So again, the utilization depends quite a lot on the characteristic of the workload that you might be running. It could be single thread, multi-threaded. It could be memory bandwidth intensive, or it could be IO intensive, CPU intensive, memory intensive, right? So depending on these characteristics of the workloads, uh, so they are classified into different buckets, and then you can optimize. For example, if you are using TPC-DS workload, or it has 99 queries, it is trying to mimic different use cases in the big data decision support system scenarios. Big Bench is again more on the big data warehouse side, and you have TP6 AI that has come up recently, which is trying to uh, more very much close to the Gemini thing, and there is no standard still that has come up with to compare the LLMs, right? So that performance matters a lot. So budget is nothing but about uh, when you're coming up with a solution package, like different system components. We have, it could be memory chip could be from Samsung, or it could be Mellanox network cards could be used, or any of these CPU could be from AMD, or Intel, or Nvidia, right? So these are pretty much the licenses are based on like VMware licenses, or it could be VDI that you could be using, right? So those licenses differ a lot based on the kind of architecture using. They would have done collaboration along with the hardware company, and then they would have come up with the, especially the cloud virtualization solutions like VMware or Citrix, some of these things, right? So these licenses as a whole, it matters a lot. We at HP we used to call it bill of materials, right? So you could do the capacity planning for capex and opex kind of operations. So DevOps again. So when we talk about the software side, more you're dealing with. I think it's been more than a decade that I worked on the software side, so I don't really remember everything on the side, the latest things there. But so you would be dealing with DevOps more of like you're creating your own instances of the transaction applications, and then whatever the code changes that's happened at the development, and it is in agile way. It is kind of uh, tested on the deployment side also by making different instances, and having stressing different load levels, right? So even all of these, the workloads that I talked about, spec CPU, so they have different load levels defined cert also for energy efficiency, and it's quite you can check the tpc.org or spec.org for details on these kind of benchmarks that are used to measure the performance of the hardware systems that we have as a standard. So continuous integration, the hardware side could be like, how the containers performance is on the hardware side. So there you could have different instances of, uh, you could be using uh, container capacity, right? Memory, the CPU threads. You can easily like kind of in the YAML file, you can define all that, right? So then you can deploy and see check the performance. So that could be happening on the container side. So the integration here is the thing, but uh, how it matters a lot, because the server, before it goes to the live to the production, then you check the performance of all this. But in live production there could be different issues. Again, that comes to the R&D teams, who, if there is any issue with the hardware level, so they look at it. It's quite a huge set of teams across the hardware. There could be HPC team, high performance computing team. There could be machine learning team. There could be benchmarking team. There could be the VMware team. So again, I'm talking about a particular set of things that I'm familiar with. The right now the majority of the companies like Amazon, Google, Apple, they could be having their own kind of setups and cloud servers and data centers, pretty much huge in this space. AWS, right? So keeping pace with the rapid technologies, uh, the technological changes is again a challenge, right? So you have the Moore's law that is coming to picture, where you have uh, kind of just a minute. I was looking at yeah. So the Moore's law, more it's about you cannot scale beyond a particular uh, set of cores, right? So it's more to do with just a minute. Let me just jumbled up in my slides. I'm just looking at where I am. Okay, yeah. So you have within chip you cannot really run too many things, right? It's like an if you're going for a train station or a bus station, you buy tickets and different counters. The counters you can have analogy like processing units, CPUs, and the queue is like all the transactions that needs to be like processed, right? So these things are quite changing at the nanometer level. The chips that you have, yeah, I think the lowest one I've seen is like maybe the 4 nanometer of AMD recently, Genoa, and there are variations of the Genoa X and more that are coming up. That's what I'm familiar with. It could be quite different on the ARM and all that, right? So how do you keep up with this? So you have to be part of the ACM conferences or international conferences, big data Europe conferences. It could be related to spec, ICPE. You have ACM, you have IEEE locally in India. So you can be part of those conferences. And also YouTube, they keep publishing a lot of videos on these international conferences that happen in this space of computing. So you can be part of those and understand what is happening on the that side, right? So how do you transition and to hardware performance engineering from software performance engineering? So if you are interested in this, I will be sharing shortly the my WhatsApp group. You can be part of it, and uh, then we can talk more on these things aspects. Transition to hardware performance engineering, it would not be so difficult, because you already know on the operating system side, on the application side how to tune. So only thing is you don't know how to tune the hardware side, and it's quite complex when you talk about different systems. HP different, and IBM servers are different. It will be AMD KVMs like are different. So you need to tune the BIOS. That's what I've seen, as a BIOS has different profiles and tuning parameters. Uh, which primarily play with kind of the frequency scaling of say, cores, and also the memory, the LLC that is involved, how the data access patterns are within the server at the CPU level, memory level, disk level. So all those matter a lot when you are trying to understand the hardware side of things. So understanding CPU architecture would be one thing, and then understanding what benchmarks are used. So benchmarking knowledge is pretty premium. There are very less people working on it, and also it is difficult to move across when you are in this network of companies like Qualcomm, ARM, AMD, Intel, Nvidia. So there are new players also like Fujitsu, Supermicro. There are all you can check out the spec members. You'll find a plethora of hardware vendors. So everybody more or less would be doing this. So nowadays the cloud, because of the cloud, a lot of things are changing. The AWS, GCP, and Azure, right? So there the cloud performance is again. Then the hardware is like totally abstracted, right? So uh, even then, the single thread performance comes into picture then. Uh, I'm not really a great expert at the deep level. There could be, like I said, uh, different teams working on the processor modeling itself, verification, validation, and development itself. There could be performance teams, right? So they could be industrial teams, could be working on the manufacturing side of things, right? So again, the system, the firmware that is used, the BIOS that is used. So those things additionally you will learn in terms of the hardware side, right? So again, OS, JVM tuning. If you take of big data, again, those the Java JVM level tunings matter a lot. Also, the if you're dealing with Java applications, of course. In case of C, you have OpenMPI, and you have compilers. So JVMTI in case of Java, and in terms of CPU, there could be LLVM. It could be different compilers that are there, right? So we have open source compilers, and then also custom compilers of each processor company, right? So you have GCC, right? So these things pretty much matter a lot as the overall performance of the system. So that's what it is tested on. So having different teams, there could be compiler team, right? So those also very niche areas of work in this space. So of course, the people who are specialized in these things, they work for these companies over a long period of time, and they move around these limited companies because the expertise is where you can use, and it is hard to find. So they are pretty much paid more than the software engineering side, because software engineering side you have a lot of crowd and easy to train, but the other side it is difficult to train and mentor. So it takes so nowadays we have the statistics that Gen AI coming up, different hardware vendors, they are coming up with their own GCCs, and I need to still do market research on that. I will come up with in future sessions about that same, on why the Gen AI is making a lot of changes in these aspects right now, right? So is it possible for you to transition to other performance engineering? Yes, absolutely, because performance engineering side. So performance engineering side is quite vast. It could be changing the code and improving the performance. It could be Scala, or it could be Java, Python, or Golang. Golang I've not really checked on the performance side, but definitely Java, R language. So because big data, data analytics, AI, they are becoming popular these days. So these benchmarking, these performance also matter. So they generally have micro benchmarks developed for these purposes. And uh, I'm just speculating that already there could be some of the LLM based benchmarks that could come up and already maybe existing. I'm not aware of it. So I'll do research on those things and talk about those things too. So definitely it is possible. but with a little bit of uh, networking and attending conferences, so you can definitely get on the other side, right? So thank you so much. That's what I had for today. And you can always reach me on dataventurex.com. You have I stay at Bangalore, India, and it is my contact details. And so okay, so now, okay, just a minute. So I will probably share later on the my profile the WhatsApp group you can join. So to be connected with me, and really thank for everyone who have joined this uh, session. So next time I will plan well and go online uh, with enough information, going live on LinkedIn. So this is my first time, so pardon me if I have anything missed here. So thank you so much. So be in touch with me to know more on these aspects of how you can transform yourself from software to hardware performance engineering. Thank you.